So yeah, today guys, thank you for joining, taking the time out of your day to join us on this session. As many of you will be aware, we've recently revalidated against RIS 11.6.01, and this session is aiming to give you an overview of the deployment concept. So we're going to be doing a few live implementation sessions, showing you how to set up a few of the VIPs and giving you a good understanding of how to set up RIS for Loadbalancer.org. And as well as that, we're going to be giving you some useful tips and tricks for troubleshooting and maintaining the Loadbalancer.org solution. As we understand, the audience is part of the services team, so all of the content here today will be relevant when managing a Loadbalancer.org solution. So, speakers and panelists today, obviously myself, Liam Canavan, I'm the Philips account manager, so I'll be handling sort of the first overview part of the session, giving you an overview of Loadbalancer.org and some of the commercial aspects of it. Then we've got Damien as well, who is one of our senior support engineers here at Load Balancer, who will be running through the technical aspects of the presentation. If we take a look at the agenda today, it is going to be an overview of Loadbalancer.org that I'll be delivering, so it will touch on who we are as a business, our healthcare specialisation, the relationship between Philips and Loadbalancer.org, and quickly touch on the new hardware update that we have made to our solution and our offering to you. Then Damien's going to run through the RIS deployment concept and then give an initial configuration / setup of the appliance in a live implementation, so you can see how to set it up from scratch. Then we're going to be deploying some of the RIS virtual services on the Load Balancer as well, to give you guys a good overview of that process. Then we'll touch on technical implementation and a Q&A. You will notice that one item is slightly changed from the agenda that was sent out, which is a review of the deployment guide, and we will be doing that in the RIS deployment concepts part of the presentation. So we'll be covering the deployment guide that we have created as well. So to kick things off from my side, who is Loadbalancer.org? So for the last 20 years here at Loadbalancer.org, we've been solely focused on developing, supplying and supporting load balancers, otherwise known as ADCs, or application delivery controllers. The product itself is built on widely used open source projects. So we use Linux Virtual Server at layer 4 and HA Proxy at layer 7. And over the years of working with these projects, we've made significant contributions to these projects and have a fantastic working relationship with the creators and the community in general. Our initial focus as a business was on the direct side, working directly with end users for their load balancing requirements. But around a decade ago, we fell into the healthcare space through working with Carestream to provide high availability to their PAC systems. Obviously, Philips then acquired Carestream, which is where the relationship started between Loadbalancer.org and Philips. Where other load balancer vendors are quite generalist in their approach to partnerships, Loadbalancer.org has been specialising in medical imaging for a decade now. And over that time, we've collaborated with nearly every major enterprise imaging vendor to different extents, be it strategic partnerships, full-blown OEM relationships, or tactical projects where we're working with end users to provide the high availability requirements for their medical imaging deployments. Now, as part of this journey, we've realised that the most effective way to work with healthcare vendors was to create strategic level partnerships to supply reliable, intuitive and cost-effective load balancer solutions. And whilst we've seen lots of similarities in pain points and requirements, what we've really learned over that time was that the key to our success was the flexibility in our approach. Now, whether this is tailoring the user interface to the requirements of your application, branding the product to align with the go-to-market strategy, coming up with custom licensing agreements, or really anything else that helps you, we've built a business model focused on flexibility to our healthcare vendor partners. Now, a key part of the Loadbalancer.org offering is our industry-leading support that comes as standard to all of our partners. Our engineers are specifically trained on the deployment of your application and come with years of enterprise imaging experience. Unlike most other load balancer help desks, terms such as HL7 or DICOM are very familiar to the wider teams. Finally, a point to touch on is that our product roadmap is largely driven by the requirements of our healthcare partners. This has not only helped to create a product optimized for enterprise imaging environments, but also we have built in the flexibility to align software releases with your product roadmap as well. So a little bit on Loadbalancer.org and our healthcare specialisation. To reiterate a couple of the points of the previous slide, we've spent the last decade gaining more and more knowledge of enterprise imaging environments and the demands placed on vendors such as yourselves. And this has been through forging partnerships with other partners such as Change Healthcare, Fujifilm and GE Healthcare. Having worked closely with all of these different vendors, we've gained a lot of knowledge relating to medical imaging environments. So we decided to ensure our product involves industry-specific features such as inbuilt DICOM health checks, as well as our recently released centralized management solution. With healthcare forming such a large part of our business, the key element of our specialization in healthcare is ensuring that all of our engineers are specifically trained in medical imaging environments. And as I touched on in the previous slide, we take this a step further for our key healthcare partners and commit to training our engineers on the deployment of your specific application. So in the event that one of your environments does face an issue, you're not passed through a tiered support system, but get straight through to an engineer with the skills and knowledge to help resolve the issue. Now, having spent such a long time focusing on this area, we now have around 1,000 active PACS, RIS and VNA deployments globally with many different partners. And also we work with many reputable government healthcare institutions such as the NHS in the UK. We have about 1 in 4 of the NHS trusts relying on our load balancing solutions. We work with the NIH in the US and the MOH in Saudi Arabia. So very reputable government institutions that we have a close relationship with. It is worth noting that our company objectives and goals are based around our healthcare partners and our vision to become the leading ADC provider in the medical imaging space. So next, I'll quickly touch on the relationship between Philips and Loadbalancer.org. So, as I touched on earlier, some of you will be aware that our partnership originated through us working with Carestream, and that started around a decade ago now. Obviously, Philips went to acquire Carestream, and that's how our relationship started. Since then, we've been working with your teams in the UK, Europe, Middle East, and the USA mainly. We have also worked with some of the teams in the APAC region as well. And this is to provide high availability to your critical medical imaging solutions, now with around 500 active load balancers in your deployments. What we've done is we've recently updated our hardware model. So this is now licensed to 18 gig of throughput, which in our experience with our other enterprise imaging partners can support projects of around 2 million studies per year. And I'll cover this hardware model quickly in the next slide. To enable you to purchase our solution via the preferred hardware vendor in your region, we worked with Dell and HPE to set up Philips specific SKUs. I can share that SKU with anyone if they are interested in what that is as well. And we've introduced a specific Philips model and pricing to match, which is a 5-year high availability bundle that includes hardware, software, support and maintenance in a HA scenario. What we do is, compared to some of the other load balancer vendors in the market, we do pride ourselves on having an intuitive and user-friendly web UI, and we do strive to reduce complexity wherever we can. So this can be achieved through tailoring our solution to your specific needs by either stripping the web UI of unused functionality to reduce the chance of misconfiguration or user error, or creating application-specific templates to expedite the deployment process. At current, Philips does not receive a tailored version of our solution, but if your teams would be interested in to look at stripping certain functionalities from the web UI, we can certainly look into this, and please do reach out to me if you want to pick that conversation up. We do plan on creating RIS-specific templates to expedite the deployment efforts, and we will be updating you in the coming weeks on that topic as well. So last thing to mention again is previously, as I've touched on, we ensure our support team not only understand generic medical imaging environments, but understand your specific products as well. Quickly to touch on the hardware unit then and what we've done to update it. So this is our new hardware offering. The interfaces have been upgraded to include two 10 gig network cards as standard on top of the two 1 gig network cards that traditionally came with the box. This means that the throughput is now up to 18 gigs, which is about 4 times the performance of the current offering, or the previous offering, should I say. The RAM's also been updated to include 16 gig as well to help with that extra traffic and throughput. Enterprise iDRAC is now included as standard with all units. The chassis has been upgraded to Dell PowerEdge R350 for availability, and the warranty on this hardware unit has been extended to 5 years as standard. But do note that there is options to extend the warranty to 7 years and even above that at request. We can work with Dell and HPE to get that organised for your teams. You will be pleased to know that this hasn't affected the cost of the offering at all, so it's still at the exact same cost as what you are using today. So at this point, I will pass over to Damien, who can run you through the technical part of the presentation today.
Okay, hello everybody. So we will now start the part that is around the technical things regarding the RIS deployment. So we will quickly go through the deployment concepts. The RIS deployment will include both layer 4 and layer 7 methods of load balancing, which we will discuss in a little bit more detail later on. Currently, the setup of the RIS is altogether 14 virtual services, as mentioned before, some of them layer 4, some of them layer 7. Some of the layer 7 ones are actually backends only, which allows you to just pull the resources and configure separate health checks, but backends do not actually have their own IPs. And we, at some point, would be looking into automating the deployment of a RIS using a JSON template that can be used by your engineers. So I will now open the draft of the deployment guide that has been prepared by our team and just briefly show you what that looks like and what it contains. So as you can see, the table of contents here, the guide covers various topics, starting with some useful terminology that is used there in the guide, all the prerequisites, what sort of the versions we support, and then it goes on explaining all the concepts regarding the deployment. It will inform you about the layer 7 and layer 4 DR mode, which are the ones that are used in the deployment. And then as well, when we get to the part regarding the layer 4, it goes into some details of what has to be done on the actual RIS nodes to make them correctly work with a layer 4 direct return. Then later on, we will have some more information that is focused more on configuring and maintaining the load balancers, as you can see. So there's some points about the initial network settings, as well as how to update the appliance and configure some of the basics like the host names, DNS, or the entity service. And then later on, there are more details about each of the VIPs that has to be configured for the RIS, which then I will actually show you how that should look like on the actual load balancer. So we won't be really getting into details of those. And then at the end, you yet again have a little bit of a tips on testing and verification of the services if they are working, as well as the configuration of the HA pair and some additional configuration like SNMP for monitoring of the appliances, as well as the email alerts should you need those. And then at the very end, we cover as well the technical support, and there's an appendix about how to generate a certificate sign-in request on the load balancers, if that's the way how you get in your SSL certificates for these services. And going back to the presentation, the next slide here shows us a brief overview of how the services will be set up. So as we have mentioned, this is 14 services altogether. As you can see, there's a lot of them being just the backends, which means they are a part of that first VIP mentioned over there that is configured at layer 7. Then we also show the methods of the persistence that are being used, which mostly are the HTTP cookies. For layer 4, the source IP is the only possibility, and then as you can see, there are the types of the health checks that are being used in that, which we'll also touch on later on. One too far, sorry. So layer 4 load balancing, as you can see, it basically works on the layer 4 of the networking model. So all that we actually can work with here is the TCP and UDP protocols. So it just works based on the IP addresses and the port numbers. There is no application awareness in this case. The good side on the layer 4 is that it is much more performant than layer 7, as we actually utilize the Linux virtual server module of the kernel, which then means that this is working in the kernel rather than a user space, which produces less overhead. As we use the layer 4 in the direct return mode, also this allows for the bigger throughput due to the fact that the traffic coming back from the real service is being actually sent straight to the clients rather than via the load balancer. And as I have mentioned before, the limitation here is that only the source IP can be used as a persistence method. As you know, working on the layer 4, we cannot do things like cookies, etc. So just to explain the layer 4 direct return a little bit more, as mentioned before, this is a high performance solution that firstly is definitely more performant in terms of the resources that are being used by the load balancer due to running in the kernel space, and also allows for a bigger throughput due to the fact that working with the layer 4DR, the setup over there allows us to actually return the traffic straight to the client. So the initial request from the client will go to the load balancer, then load balancer based on the algorithm will choose which of the RIS nodes the request will be sent to, but then the application replies straight to the client, which means that the traffic is faster. And then we also do use layer 7 load balancing in some of the cases. As mentioned before, it works on the layer 7 of the network model, so it is application aware, which allows us to have much more flexibility than with layer 4. This allows us for directing the traffic in a smart way using the ACLs, which is why we segregate some of the services in the backends, and then based on those ACL rules, we send them to the correct backends. There is a possibility of inserting headers into the HTTP requests on both requests and as well as the responses. We have more load balancing methods available at the layer 7 as well. So we have what we call a first balance method, which allows you to set up sort of active passive deployment, which means that you would be mostly sending your clients to one real server, while the other one would be used as a passive when the first one fails its health checks. Also, there's more of the persistence methods available. Last successful, that is the one that is available for that mentioned before first balance method, which basically means that we will send it to the real server that was the last one to pass its health check. We still can use source IP, obviously, And then there are things like HTTP cookie, which means we will insert a cookie with the ID of the real server that it has been used by a client, and allow the clients to go back to that server during the persistence window based on the content of a cookie. Layer 7 load balancing, as we mentioned, is actually handled in a user space, so we use HE proxy with the version 2031, which is a long support version that we are currently running on our load balancer. And now to explain how the layer 7 SNAT deployment works. As mentioned before, unlike the layer 4, the HE proxy is basically a full proxy implementation where client requests will be passed on to the load balancer. Then yet again, load balancer, based on the algorithm, will choose one of the RIS nodes to which it will redirect that request. If there are any ACLs or header modifications, the load balancer will also do that, send it to one of the RIS nodes, and then the RIS node actually replies to the load balancer, and then load balancer sends it back to the client that has initiated the original request. So as you can see, all the traffic is going through the load balancer in that case. The good point about the layer 7 is though that as it works on the higher levels, it actually can be working across multiple networks, and it does allow to send traffic to any server that actually can be routed to, unlike the layer 4, where you actually have to have the direct connection to that particular subnet where the servers are available. Okay, so just to talk a little bit more about the layer 7 and the configuration of it. As mentioned before, we do have the what we call a listen statement in the configuration, which is the kind of full virtual service, which will be listening for incoming client connections, as it will be set up with an IP address. Such virtual service can have own health checks, can be configured with some ACLs that will allow us for switching the content regarding the sending the traffic to different backends, and then it will be allowing you to distribute the traffic to different real servers, as well as the backends. The backends, though, they cannot listen directly for the client connections. As mentioned before, they do not have their own IPs. They are just pools of the servers that are being configured in the HA proxy, and only the front end can send the traffic onto those backends. So yet again, the backend can have its own health checks, which allows us for a better kind of granularity regarding the services that are currently working, and it allows you to distribute the traffic to the pool of real servers defined in such backend. And now let's talk about the ACLs, so the access control list. That allows you to switch the content a bit. As said before, with the RIS deployments, we use multiple backends, and when we go further, you will notice that we have a lot of ACL rules on that main VIP over there, the main virtual service, which then sees the URLs, for example, and for the particular URLs, it actually redirects to the backend that is associated with that URL. So the example here shows you that we can match the full path, we can match the beginning of a path or end of a path, or the query that is included in such path. There are also ACLs that are based on other kind of requests, and we will go into that while setting up the VIPs during the live presentation. Okay, which will be starting now. So the firstly, before you start configuring the load balancer, it is important to go through a little checklist and make sure that certain things are ready. So we will obviously need to allocate the IP addresses in the network for both the primary as well as the secondary appliance. Make sure that you have the details of the DNS service for that network as well as the default gateway. A little bit of a sanity check. It was also worth to kind of run a ping or something just to double check if those IPs are actually free, not in use. And then, as it is hardware that you're dealing with, make sure that the space in the rack is available so you can actually connect your units. We will now be doing the initial setup of the load balancer. There are points over here that then you can refer back to when we send you the presentation, but I will just carry on with doing that live. So if you just allow me a moment to get to, in this case, actually a virtual machine that I have. And this will now show you. This is how the main screen looks like after booting. So it will present you with a prompt where you can actually log in for the initial setup. As you can see per the instructions on top, you log in as setup user and the password is also set up. Then that will turn on the setup wizard. And first question there is if you would like to continue, as it will, should you already have your appliance configured, this will wipe the configuration that is already on it. So we confirm. Then the next question is about the peer recovery. This is for the disaster recovery scenario, which we will actually also discuss later on in the presentation. So as this is the initial setup, we will say no to that. At the moment, we will not be setting up the centralized management as well. This is something that possibly Liam will discuss with you as well regarding support for the centralized management of your appliances. Okay, so let's just wait for it. So now we will be shown the available interfaces. Just continue over here. Should you need to create bonds, this is the point where you can create bonds with the both mode 1 and mode 4, so LACP available. Yet again, should you need to create any VLANs at this time, that was the prompt over there. In here, we select the interface, so you can select the interface that you will be configuring as your management interface. If you had created bonds, the bonds would be visible in here as well. So we then go on to select. And now we will give that machine an IP within the subnet that is available here. 18. Okay, and then yet again we will set up a gateway. And we need a DNS, which can be this. You can also set up a secondary DNS. I'll just go ahead to make it a little bit quicker. We just go ahead and just carry on. The last question here is to set the password. It is actually worth noting that should you set up that password on your initial deployment, and if you ever go back to the setup wizard, you won't be prompted for setting up the password again. It will only ask you to change the password if the password is set to load balancer, which is the default. If you change it to something else, you won't be asked again, so it will actually require opening a ticket and help of an engineer to reset the password should you ever lose it. After the configuration is complete, you'll be able to actually access the load balancer via the browser, and this is how the out-of-box load balancer looks like. So this is where we would have then initiate the configuration of the VIPs and real service as well. Let's just go back to the presentation for a moment. So as you have seen, all the steps that I have went through are here, and then, as we said, we move to the browser just to verify that this IP is definitely up and running on the load balancer, and you can access the web UI. And then we will be going into the configuring of the VIPs for the RIS services. So I will get back to my load balancer. So as said at the beginning of the presentation, we are dealing here with both layer 4 and layer 7 virtual services. Let's start with a layer 4 virtual service. As you can see in the web UI, you just simply choose add a new virtual service. We will give it a name. So in this case, we have R2I over there, which will be both TCP and UDP as a protocol, and then the forwarding method that we will be using is direct routing. And actually this one is using a wildcard here, so it actually covers every single port. And let me just give it an IP that is actually in my network here. And we update. Apologies, I may not. Oh yes, apologies. I have run through the setup wizard, so as I mentioned myself before that, my other IP address has been taken down. So that is how you would set if you have like a 2-arm configuration. This is how you would set the second IP address in another network. You just actually go to, just to revise that, local configuration, network interface configuration, and then you can do it from here. Likewise, if you have not decided to set up bonds during the initial process, you can do it here, and same with the VLANs, they can be added afterwards with this web UI here. So let me just fix that mistake and put that IP back on. So I can add this layer 4 virtual service here. So that was R2I, and we will give it, in this case, the IP of 10.10.1.201. And this one listens on all ports, and it is the TCP and UDP, both of them. So now that we click update, we should create a virtual service which creates the floating IP on our load balancer as well. Then one thing that we need to do as well here is, after we click modify, we can set up the things like persistence. So by default this is enabled, and it is 300 seconds, so 5 minutes. And then we can actually choose the health check, which in this case we will use a ping. So we can actually do an external script which covers both the IPv4 and IPv6 ping. The check port for that script is irrelevant, but it allows us to specify the port for this checks, which we will see when we will create layer 7 as well, because we use the HTTP requests over there. So after clicking update, that will be our VIP created. As you can see, it's already here. As we do not have any real service at this moment, it will report as down. So let me just quickly fix that. So we will add a new real server. So this can be done either from the system overview or just here from the left menu. We choose layer 4 real service, and then we will see there's, so let's call it DC1, and then the IP address here is then 10.1.11. So that'll be a real server. And now the health checks should start working and show us that one in the system view as up. So as you can see, the green arrow here indicates that all is functioning with that virtual server as well as the real servers. We will now carry on further with setting up the layer 7 virtual service. So we yet again, in a similar manner, create a new virtual service, give it a name. In this case, that is actually an RIS. We will give it an IP and 200, and also I'll use 201, 202. This one will actually use port 80, and this is an HTTP mode for that one, as this will be using some of the ACLs. There's also TCP mode available, which is kind of more similar to layer 4, as it only works on the TCP streams. We will add that one. And as you can see, we have RIS here. And now what we will do as well, we can create a backend. So after clicking on the advanced button over here, you will see that there's an option to create a backend only. And that will then just need a name, which in this case is RIS_EM. As both of those are configured now, or actually just created, we can actually carry on with the further configuration. In terms of the RIS, we would actually set it up as it is a front end, which will not be really handling traffic. We can actually set it to no checks, always on, and the method of the balance method is set to the weighted list connections for that one. So we'll just update that. And then the next one, there is EM here. It's just a backend, but yet again, it will allow us to do pretty much the same. The only difference is it does not have an IP that is fronting the clients. And for this one, we will set up a negotiate HTTP check, which is one of the most popular checks that is being used here with this application. And what we will need to set is an URL here, which is long and complicated. CHRIS. This part of the URL will actually depend on your environment. So this is basically your environment name, from all I understand. And then the rest of it is sort of common in all the deployments. And API. Trying not to make any typos in there. And then it's actually health check again. So, and then the one last thing to set is the expected response. So we basically, it could be left empty in some of the cases, which then means that we basically are expecting a simple 200 OK response from the HTTP, or it can be set to any arbitrary string that the application would return. So in this case, it should be equal true. So that is what the RIS application will reply to us. And as we update that one, so as you can see, now that we have modified those, we have been also prompted to reload HA proxy. So until you reload HA proxy, those services are not available yet in the system overview. They are not visible here. Just as we would have been asked to reload the HA proxy one more time after making another change, I'll just quickly add a real server here. We can specify the port if we want to listen on a particular port, if we want to bind to a particular port, leaving it open will basically inherit the port from the virtual service configuration. So if we had it 80 here, it will also be 80 there. Let's reload the HA proxy, and now we should see those. As RIS has no real service configured, this is not replying yet. And then the RIS EM, if I made no mistakes, should actually come up as available. So then that is basically the three kinds of virtual services that you mostly will be creating. And then also on top of the actual layer 7 real server, should you need SSL termination, if you're doing it on the load balancer, this will also require you to upload a certificate to this one, but for the purpose of today's presentation, oh, actually I do have an uploaded, oh no, sorry, this is the virtual service. So we just pick up the virtual service from the list, which is here the RIS. So this is also only available on the layer 7 VIPs. And then here you would choose the SSL operation mode, so high security is possibly the one mostly recommended. And then if you had a certificate uploaded, you would see that over here. So for the purpose of the today presentation, I'll just use the default self-signed certificate, and we will reload the tunnel. And also to create correct bindings, we will reload HA proxy. As you can see, then there is a padlock here that will indicate that this service has an SSL termination in front of it. So now just moving on to the tab over here. If you look, that is how a RIS deployment looks like in full after configuring all the virtual services, health checks, and adding the real service. So let's move back onto the presentation for now.
See if there's any questions.
And we will be moving on to the testing of the appliance now.
We
Liam
do
is
have
checking
one question. It is, did you configure R2I VIP as persistence, just for example? Till now, R2I was not configured as persistence.
Oh, I might have then gone off the script a little bit. If it doesn't have persistence in the deployment guide, then this is just me. The default setting that load balancer will apply to all the newly created VIPs is the persistence of 300 seconds. But if I might have made a mistake here, then you would just simply untick the box saying persistence, and this will be service with no persistence. So that is, if that's the case in the guide. So let's go now to testing of the appliance. So we'll just give you some guidelines, tips on how to carry on some troubleshooting should you have any issues with your services. So as you can see, this is the system overview. So as we have seen on the load balancer that I've used for firstly showing the configuration, how it's done manually, or as well as the other one that I had prepared ahead. The green arrows are indicating that everything is fine, and they being shown on both the real service and virtual services levels. Then on the virtual service, you may also have the yellow triangle that will suggest that the virtual service as such is still operational, but some of the nodes are actually unavailable, because as we still have at least one real server, we will be continuing to work and sending traffic to that one real server that is available, but we won't be able to route any traffic to the server that has not passed the health checks. And then the last example over there, as you can see, all is red, which means in this case, both of the nodes that were added to this pool have been failing the health checks. and they are in this case also taking the whole virtual service down. For the maintenance, you have two modes. There's a drain and hold. So this is useful when you schedule the maintenance. Drain is a kind of a way to actually do the closing of the new connections. So it won't allow you any new connections to the server, but it will continue serving the connections that have been initiated, or in case of the services that do have some persistence after the connection has been stopped to the server. If the client is within the period of the persistence, they will still come back to that same server, even if it is drained. Hold on the other side, it just simply removes the real server from the pool, makes it unavailable, and won't actually direct any traffic to that server further. So even if the client has been connected to that server, their connection will be broken and they'll be redispatched to the server that is still available. Now, further discussing the server status, as you can see, the failure of a health check will be indicated by the red arrow, and then, as you have seen me setting up those in the web UI, after you go into the details of your virtual service, you can establish what sort of a check has been set for that particular virtual service, which will then kind of allow you to think of the troubleshooting method. So like say the check was ping, then you should be just checking if you are able to ping the machine from the load balancer. Now we, as mentioned before, we normally run in an HA setup. We have the high availability node. So this will consist of your primary and secondary appliance. The primary appliance is the one where you should be making your configuration changes, and the secondary is usually staying as a passive appliance, and it fails over if the primary is down, either due to some issues or say it is down for maintenance while running an update, etc. Okay, so here you can actually see how to force a failover yourself, as I mentioned, in terms of your primary going down for any reason, whether that's scheduled or not. The secondary will see that the other node is down and will just take over. But should you actually have a planned maintenance, it might be a better option to just simply do it from the web UI first. So if you navigate to the node that is at that moment passive, then you will see that banner on top of the system overview page, where you click on the advanced button, and then that will show you a button that is called takeover. Clicking on the takeover button, that will trigger a prompt from the browser where you just need to say that it is okay and you definitely want to carry on with that action, and this will initiate a failover between the nodes.
Just if we could pause there, Damien, we have another question in the chat. The question is, only physical devices allowed for RIS packs or virtual load balancer is allowed? At current, Loadbalancer.org will only be supplying Philips with hardware units. We haven't validated against the virtual solution. So you might be able to use other load balancers virtualized for the RIS and packs, but from Loadbalancer.org, it's only hardware we'll be supplying. And a second question is, how many models do you have? There are some differences in cost and throughput for each model. No, we actually have standardized on one model, which is the hardware unit I showed at the beginning of the presentation. The cost has not changed for updated hardware compared to the original units that you have been using in your deployments. So no, there is one model and the cost is the same. The throughput level is 18 gig as standard for that hardware unit. So just to recap, one model, one cost and one throughput, which is 18 gig of throughput as standard.
Okay, thank you, Liam, for answering those questions. And now we will get onto some commands that are helpful with troubleshooting, as well as so on both the the load balancer as well as on the real servers. So as you can see, there are types of checks that we would do, the health checks like ping or connecting to port or negotiate HTTP. So as you can see, this simply are the commands that you would have run in order to confirm that those things are fine. One thing that I would like to point out here about ping, for example, this example is from the Linux, as the load balancer is based on Linux. So it is actually quite important that you specify the number of counts of how many pings you would like to send. I know that on Windows systems, this is by standard 4. So if you just say ping and an IP address, it will actually do 4 checks. With Linux, you would be doing that until you actually stop the ping. So that is actually worth mentioning. So as mentioned before, we would discuss some commands that can be used on the load balancer as well as on the real servers, starting with those on the load balancer. So for example, nmap is included on the load balancer. Nmap allows to do scan ports, and just in the simplest form, you can do just nmap and the IP of your real server, and this will list the ports that are open on that real server. It will point also if by any chance there is a firewall on that port. So if the port actually listens on but is being filtered by a firewall, this will also be shown. And obviously, if there is a firewall in between the load balancer and the real server blocking that port, then the load balancer is not able to carry on with the health checks. So you will see that server as down even though it isn't. Then we have NC, which stands for netcat. So this is netcat command that can be used to check what if the port is open. So that simply you specify the netcat command over there, the IP, and then the second part over there, that is port. So this will basically work same as telnet, if you're familiar with that. And then the last command that will list over here is rping. So that basically is an ARP that will also show this is kind of a ping that will also show us the IP information. So it will give us the MAC address of the IP that is being queried. It is helpful if we would like to find out about the IP conflicts. So if you have 2 servers with the same IP configured by a mistake, then you will actually notice that those pings are coming back with 2 different MAC addresses, as both of the machines will actually reply. And then there are 2 commands that are quite useful for running on the real servers, and those very often you will be asked for those should you come to the support and have any problems. You might be asked to actually prepare those information for us. So the ipconfig /all, and then there's a redirect, so we can actually write it to a file. So this file can be shared with our team. So this will show us the information about the network interfaces configured on the real server. And so this is very helpful when investigating layer 4 DR issues. Likewise, NetStage dump, that will give us more information about the settings such as weak host, and this is something that has to be accounted for while setting up the real servers for layer 4 DR. So those 2 commands are the kind of a troubleshooting that you can do on your RIS nodes. So now we will also do the disaster recovery. So if we just talk about that for a moment. So in some unexpected events, say a lightning hit your DC and, well, the PSU is now need a replacement. well, you may actually end up in the scenario that you will need to replace the machine as well. So should that ever happen, and you end up with a single machine running in your data center and then bring in a new one, you would be just going through that process that I have shown you on how to set up the initial configuration and kind of thing. And then you have that prompt over there regarding the P recovery. So then in this case, you'd have choose yes, and then you'll be prompted about a few more details. So you will choose the IP of your currently running node, and it does not matter is the node that still remained active. So it doesn't matter whether it be primary or secondary. If you had to replace your primary for any reason, then the secondary will be running as active, and it actually has a backup of configuration of your primary node as well on it, which allows us for this process to be triggered. Then the next thing, after you have the IP address over there, you will need to also put the password of the peer node from which we will be getting that configuration. Afterwards, same like while doing the regular initial setup, you'll be asked if you want to configure all as shown in that summary. And then after the configuration is complete, the backup of the other node will be pulled from the one that has remained active. What is very important for all the troubleshooting is obviously the logs that are available in the load balancer. So in the web UI, you can see logs that are named such as load balancer, which will have the log of all the administration tasks, all the notifications that you have seen. So any prompt that you might have seen and possibly disappeared, that will be recorded over there as well. Layer 4, this shows you the information about the layer 4 services such as failed health checks, for example. Layer 7, likewise, depending on the levels of the login that are set, you may record as little as just the state of the health checks or every single HTTP request that has happened. SSL termination, STANL, that is the log for all your SSL termination services, which will contain a lot of verbose data about the from the OpenSSL about the SSL handshakes happening between the clients and servers. Then Apache and Apache error, you can use those to diagnose some issues with the web interface should you have any. So you can actually see the user access log over there and any errors that might be happening with the Apache instance or PHP. We also have some reports available, such as layer 4 status, which will show you the current weight and the number of the active and inactive connections of each of the real servers that are configured in your layer 4 virtual servers. Likewise, we have the layer 4 traffic rate that will actually show you the throughput of those connections to the real servers. Then we have the traffic counters that show the volume of the traffic since the last restart of the appliance or just the layer 4 service. And then layer 4 current connections, which will show us the state of the current connections, such as it will show us if there was a SYN between the clients, etc. So this is quite a good tool for diagnosing any issues with routing or app-related problems. So this is what you will look at when configuring layer 4 direct return. Likewise, the current connections here with the host names. So it just will produce the same report, but will also do a DNS lookup against the name of each IP address. And then there are also reports on layer 7. So we have a layer 7 status, which opens a separate tab that produces quite a big table that has a lot of data regarding all of the virtual services and real servers. So it will show you things such as when has the last health check failed or passed, the number of connections, as well as the throughput, etc. And then layer 7 stick table is what you can actually see if you have persistence on the servers, different than a cookie. As cookies, we do not keep the stick table because it's based on the cookie that client has, which basically just has an ID of the real server. But should you be using some other methods like source IP in the layer 7, then it will actually show to which real server such IP is assigned at that moment. And there's also graphing available, so you can see various graphs and such as connections or throughput, and you can see them by for particular visits as well as for particular real servers, and then you can actually see them as hourly, daily, weekly. So it will show you the last hour, last day, or last week, or even a year in a single graph. And this is where on the web UI you would find those. So maybe actually wasn't part of the Canva. Oh, sorry, just wanted to actually. You could actually do that a little bit better. Let's do it live. So as you can see, the left-hand side menu here shows you the reports. So that's where you can see reports. That is a very useful tool for layer 7. As I said, there's plenty of information over there. And then likewise, logs are available, all of them here. At the moment, I don't think there's been a lot of traffic here. At one point, I have been setting up the servers. You can see some health checks work at various points. So this is how it looks like. And let's just go back to the presentation. So we will go and talk about the backup process now. So we have obviously a possibility of creating backups on your load balancers. That can be done via the web UI, and same on the left hand side, the menu, you go to maintenance and then the backup and restore, and then there are some tabs over there, and under the backup tab you will see that, well, at the bottom of the page you can create the local XML backup. So this will just do a sort of a snapshot of the configuration on the load balancer itself. This is the sort of the snapshot that we just keep for a short period of time, as with every change that you will make, this will be overwritten by just the previous copy of the XML that has been taken before making a change. So it's kind of the n-1 configuration, if you will. We also have full backups that you then can store outside of the load balancer. These are not only having your XML configuration, which is where you can use all your virtual services set. They also will contain things such as any manual configuration that might have been configured, which is then outside of the XML firewall scripts, PICBR, the policy-based routing rules, even authentication settings should you set up an Active Directory or LDAP, for example. Also, it will contain your license, which is also quite a good thing. As you can see, there's a couple of items over there with an asterisk to their name. Those are the sensitive data, such as SSL certificates, should you have any SSL terminations, as well as the SSH keys, which are the way that the nodes actually utilize to sort of speak to each other via the SSH without using the passwords. So if you create such backup with and provide a password to secure it, those items will be included, and this will allow you to then use them to restore a pair of load balancers. So if you take one from your primary and one from your secondary node, then you can actually just restore them, and they will be already paired because they have all this information, especially the SSH keys are needed here. So this is how you would restore a configuration on load balancer. There's few options here. So with the files that can be uploaded, we have the zip file, which is the current method, the full backup. You could upload a certificate archive in TIGZ format, as well as the XML backup. This is a kind of a legacy method. So if you were using our load balancer and have this sort of a backup, then you can still use it. But for anyone who will start using load balancer from now on with the new version, you will only have the full zip backup. And as you can see, there's also an option to restore from last local XML. So like I said, if you make a change and you see that something is not right after making that change, you can actually easily go to that restore option, click that button, and this will revert the last change that you have made on the load balancer. And the last point today is, I believe it is last point, is the contacting support.
So just before we get up to that, there is another question. Is it possible to back up only the layer 4 and layer 7 configurations?
So this is what the XML would have done, the layer 4 and layer 7 configuration. So that is the option that you have locally. So at the moment, what we do is we actually do the full backup of all the elements that are included. So this will have your layer 4, layer 7, as well as the other mentioned items. So there's no actual way of having that separately, but that kind of would have been the case with the XML, because XML do have some other bits as well. So the layer 4 and layer 7 on its own is not available. There's a similar thing in a way, but as mentioned, this is something that we would like to work on with you guys. We do have the thing that is called template exporter. So let me just show you that on the load balancer for a moment. So as mentioned before, as we do not have it yet ready for your deployments, we were not planning to discuss that, but for layer 4 and layer 7 only, you could actually use that, which will produce a JSON that then can be exported, but it works a little bit differently, because when you import it, it only has some of the settings. So as it is meant to be a template, then you will be asked to provide the IP addresses, etc., to actually configure that. So there is a way of exporting just the layer 4 and layer 7. But like I've said, this is not something that we plan to discuss in detail, but in future there possibly will be such a deployment template for Philips, and then that would have been a kind of a general configuration that can be used for any sites. Okay, so let's just go back to the presentation. So we will be now discussing on how to contact the support. So as mentioned before by Liam, we have a tierless technical support team. So there's no like tier 1, tier 2. You will straight away have an engineer working with you on the ticket, and we do obviously try to pick up the tickets in a way that they are most suitable for the person that will be handling that. The tickets can be raised just by sending an email to support@loadbalancer.org, or you could also give us a call on one of our office lines. So then here we outline some steps that you would be taking when contacting support. So there's technical support download. So this is kind of a archive that contains logs, configuration, all the useful information for these support. So you can actually get that and send that to our engineers with a short explanation of the problem, which will allow us to straight away start troubleshooting. And what is also kind of helpful is to know the end user's company name, so we can also kind of pinpoint that end user in our help desk and see if they have had any previous tickets. So we have kind of a better understanding of the environment and the situation. So as said, you open a ticket via email, or you can call us as well, and then you will get someone assigned to that ticket. And should there be a need for that, we can also organize a remote session. But as I mentioned, the technical support download is usually the first thing we would be looking at, as it has all the necessary information for the troubleshooting. Okay, so here's the brief explanation of what you could expect in such technical support archive. So you will have, yes, as I mentioned, the log files, the configuration, the layer 7 stats page that I have shown you, the output of the layer 4 current connections, as well as some output of the various system tools, such as we will see, for example, what IPs are configured on the load balancer, how much disk space is available on the load balancer. We would also see the graphs, which is kind of helpful, say with performance issues, because we can then see should the system be under stress, perhaps. So that will be shown on the graphs. And here is the kind of a little screenshot showing how to generate such an archive. So from the web UI, you would have gone to support, which is just at the bottom of the left-hand menu over there, and you have an option there saying technical support download, and then simply click on the generate archive button, and that will start creating an archive that then your browser will straight away download when it's ready. And if that is under 20 megabytes, I believe usually that's what email would accept, then you can just attach it with your email when you send the initial support request. Should it be larger, please open a ticket, and one of our staff members will also share a link with you to the upload server where you can upload such bigger technical support download.
Yeah, appreciate your time, everyone. Give you a bit of time back from the session, so thank you very much.